Assalamualaikum Dr. Arif. We are from Group 1. We're going to present to you the experiment 4, which is application of first and second laws of thermodynamics. These are our team members, which consists of 4 members: Aliana Suha, Izzatun Nazila, me myself, Farisha Irdina, and Putri Nur Emilia Roslina. For the introduction, the first law of thermodynamics is also known as the principle of conservation of energy. It states that energy cannot be created or destroyed. In essence, energy can be converted from one form into another, and the total energy of an isolated system is constant. According to second law of thermodynamics, the heat transfer occurs spontaneously only from higher to lower temperature bodies. Heat can be transferred from cooler body to hotter body if only there are an external work that being performed on that system. The theory of this experiment is the exchanges of external work and heat complete the energy balance. Energy balance, or the first law of thermodynamics, referred to as the conservation of energy principle, which means the energy can neither be created nor be destroyed. The basic calculation of energy balance for the system is as below, which is E in minus E out equals to E system. Delta U system equals to 0. So delta U system is equals to delta U hot water plus delta U cold water equals to 0. But in this case, we are using oil, so the cold water is replaced using oil. So MCP in bracket T2 minus T1 hot water plus MCP in bracket T2 minus T1 cold water, which is oil, equals to 0, where M is equals to mass in kilogram, Cp is heat capacity in kilojoule over kilogram Kelvin, and temperature, T for temperature in Kelvin. So according to Cauchy's statement of second law of thermodynamics, it is nearly impossible for any system to operate in a way such that the sole result would be a transfer of energy by heat from a cooler to a hotter body.
Next, we move to experimental setup and methodology part. For the experimental setup, we do need a thermometer, small beaker, container, heat-resistant glove, electronic balance, retort stand and clamp, stopwatch, hot plate stirrer, funnel, and palm oil. For the methodology part, first we have to measure the weight of the empty small beaker, record the weight as shown at the electronic balance. For the second step, we will measure the weight of the container and record the measurement as shown at the electronic balance. Next step, fill the small beaker with tap water and record the weight of the water that we fill in the small beaker. Place the small beaker that containing water on the hot plate and turn on the switch. Heat the water until reach 80 to 100 degrees Celsius, and don't forget to put thermometer to measure the temperature. After the temperature of water reach 80 degrees Celsius, we are using a heat-resistant glove to place the small beaker that containing water into the container. Next, we pour palm oil into the container until the level of the palm oil is the same level as the water in the small beaker inside. Next, record the temperature of the water and the oil every 1 minute by using a stopwatch. Continue to record the temperature every 1 minute until the water and the oil reach the same temperature, which is thermal equilibrium. After it reaches the same temperature, take out the small beaker and measure the weight of the water in it. And the last step, don't forget to measure the weight of the palm oil that we use in this experiment.
So I will proceed with results and calculations. In this experiment, we collected the data for mass of empty beaker, mass of beaker with hot water, mass of empty big beaker, mass of big beaker with cooking oil, the initial temperature of both hot water and cooking oil, the specific heat capacity of hot water and cooking oil. After finished doing the experiment, we recorded the time, temperature of hot water and temperature of cooking oil in table 1. We also calculated the temperature differences in hot water and cooking oil by subtracting the final temperature with the initial temperature. In this table, it can be seen that the temperature differences in hot water is decreasing, while the temperature differences in cooking oil is increasing. Next, we have calculated the mass of hot water and cooking oil. So after we got the final answer, we change it to kilograms so that it can be cancelled out. Next, we calculated the temperature differences, which is delta T for both hot water and cooking oil. We add it with 273.15 to change it to Kelvin, and for the hot water we got negative value, and for cooking oil we get the positive value. After we have calculated for the mass and temperature differences, we calculate the energy changes, which is E equals to mc delta T, which is M is mass, Cp is specific heat capacity, and delta T is the temperature differences. So we also got negative value for hot water and positive value for cooking oil. According to the graph of temperature of hot water and cooking oil versus time that we have plotted, it can be seen that the temperature of hot water is decreasing while the temperature of cooking oil is increasing until 26 minutes, where this means they have reached an equilibrium where there is no heat transfer between these two mediums. Let's move on to the discussion. After doing this experiment, it can be seen that the temperature for hot water evenly dropped from 0 to 5 minutes. Then it is slowly decreased to the end, which is 26 minutes. For cooking oil, the temperature slowly increased until it reached to 38 degrees Celsius at 26 minutes, which is the same as the hot water, which means they both have reached equilibrium. Based on first law of thermodynamics, energy can be neither created nor destroyed. It may converted from one form to another. In this experiment, there is no heat transfer anymore between these two mediums. When equilibrium has been achieved, which is at 38 degrees Celsius, thus obey the first law. It is proven that all kinds of energy in isolated system remains constant. It also states that the change in system's internal energy is equal to the total of heat received or lost by the system and work done by or on the system. Based on the graph, the slope represents the rate of change in temperature of hot water and cooking oil. This means hot water releases energy, therefore negative gradient are shown, while cooking oil display positive gradient as it absorbs energy from hot water. Second law of thermodynamics stated that heat always flows spontaneously from hot to cold regions. The magnitude of the graph portrays that hot water releases more energy as the temperature decreases as time goes by compared to cooking oil, which absorbs more energy as the temperature keep on increasing until we get a constant reading for both medium. As we keep on observing and the temperature is still maintained, we assume that it has reached equilibrium. So it satisfies the second law, whereas heat is transferred from high energy to low energy level. But it can also be concluded that heat may be lost in the surrounding, as this experiment is conducted in an open system.
For the conclusion part, from the previous graph, we can conclude that the temperature of cooking oil increases over time while temperature of hot water decreases over time. The first law of thermodynamics is obeyed when the temperature of both cooking oil and hot water is constant at 38 degrees Celsius as it achieves the thermal equilibrium. In addition of heat transfer and work crossing both system boundaries, mass carries energy with it, influencing the exchange of energy content during the mass entering and leaving of the system. This is proven by the value of energy change calculated in this experiment, which is negative 37.61 kJ for hot water and 13.53 kJ for cooking oil. Second law of thermodynamics
is followed when there are transferring of heat from higher temperature to lower temperature. This can be seen from the graph as hot water transfer the heat to cooking oil medium, making its temperature become decreased at the end. In final analysis, the objectives of this experiment are achieved and our experiment is considered success. Safety procedures. First, ensure that the fan is turned off to avoid disturbance due to wind when the experiment is conducted. Second, make sure ice is perpendicular to the reading of thermometer to prevent parallax error. Third, place the tip of thermometer inside the solution and not at the wall of the beaker because temperatures are different between them. Fourth, use protective gloves when handling with the hot beaker to protect your skin from thermal burns. Last but not least, this is the list of references that we use to give us some idea to write the lab report.